Hydrogen is the most abundant element in the universe, thanks to it being simply one proton paired with one electron. Here on Earth, we usually see it bound to oxygen to form water, and very rarely hydrogen atoms pair up and exist as a gas in our atmosphere. But theoretically, in the right conditions, hydrogen alone can act as a liquid metal, and learning more about it could answer some mysteries about planets in our solar system. We know Jupiter and Saturn are mostly hydrogen based on their densities, which is why they're called the gas giants. But they're not puffy clouds all the way down as the name might suggest. Only the thin outermost layer is gaseous. Under that, the pressure compresses the hydrogen into a liquid state, and further down still, the hydrogen takes on metallic properties. Most elements in the periodic table are metals. Their defining characteristic is they pass electrons freely amongst each other, like a shared pool of electrons. This makes them good conductors of heat and electricity. Normally, the hydrogen we see on Earth doesn't behave like a metal, but at about 13,000 kilometers below Jupiter's gaseous surface, things are different. Like a substitute teacher, with enough pressure, those hydrogen molecules snap. In fact, the hydrogen atoms dissociate entirely into free electrons and protons. The pressure inside Jupiter gives it the properties of a metal. Those electrons can flow freely from proton to proton, making the hydrogen conductive. We think this metallic hydrogen could account for the magnetic field surrounding Jupiter and Saturn, instead of a molten iron core like inside the Earth. But to understand metallic hydrogen better, we have to make it, and that is no easy task. It's not like we can scoop some up from deep inside Jupiter. Instead, we have to recreate those conditions somehow here on Earth. And I am very happy to report that one leading method involves giant lasers. The lasers, all 168 of them, are used to send shock waves through a sample of ultra-cool liquid deuterium, an isotope of hydrogen with one neutron. The waves compress the deuterium to 6 million times Earth's atmospheric pressure, while keeping the sample below 1700 degrees Celsius, or what physicists call cool. At least they think it's that cool, because measuring the temperature inside the shock wave isn't possible, and instead is inferred through computer simulations. Still, the scientists concluded liquid deuterium becomes metallic at 2 million times the pressure of Earth's atmosphere. That contradicts another lab's findings that the transition happens at around 3 million atmospheres of pressure. Each lab politely and professionally says that the other one must have incorrect temperature estimates and that their own results are the true and correct ones, which is about the closest scientists get to reality show drama, and I, for one, am living for it. There's been even more drama around a 2017 Harvard experiment's attempt at making metallic hydrogen. Using the tips of two diamonds like a vice, scientists claim they crushed a hydrogen sample to nearly 4.9 million atmospheres, until it wasn't just metallic, but solid as well, a world first. They were going to send it to another lab for study, but wouldn't you know it, just before shipping it, they decided to check the pressure with a laser one more time for good measure, and the diamond shattered to dust. The sample was lost. This has led other scientists to speculate that it didn't actually happen. Still, the Harvard scientists think the lost hydrogen could still be in a solid state, even with the pressure lifted. It might even be a room temperature superconductor, which would revolutionize material sciences. But finding the 10 micrometer wide sample in a pile of diamond dust is next to impossible. Darn. Funny, we go through all this trouble to create a speck of metallic hydrogen, but thanks to Jupiter and Saturn's vast sizes, it's the most common form of hydrogen among all our planets. Sometimes there are drawbacks to living here on Earth. While you're here, subscribe for more videos like this one about how Jupiter could be the reason for life on Earth. Some scientists don't believe the Harvard experiment made solid metallic hydrogen because at high enough pressure, the hydrogen can diffuse right through the diamond. Thanks for watching, and I'll see you next time on Seeker.